Hello there, and welcome back to Sleep Science Daily. Tonight is different. Tonight we are not going to a planet. We are not tracing the edges of a galaxy or watching a star being born. We are going somewhere no human has ever gone. No probe has ever reached. No signal has ever returned from. Tonight we are going inside a black hole, not around it, not near it, inside. And before you close your eyes and let the words carry you, I want you to know something. What you are about to hear is not science fiction. Every idea in tonight's journey comes from real physics, real mathematics, real minds that have spent decades staring at equations and asking the most uncomfortable question in all of science. What actually happens in there? Because here is the thing nobody tells you. We have photographed a black hole. We have detected the sound of two black holes colliding, a sound that traveled for 1 billion years before whispering through our instruments for less than a second. We have watched stars near the center of our galaxy moving so fast, so strangely, that nothing else could explain their orbits except something 4 million times heavier than our sun sitting invisible at their center. We know black holes exist. We just do not know what they are on the inside. And that gap between what we can see and what we cannot is where tonight's journey begins. So let your body settle now. Let the weight of the day go. If your eyes are already closed, good. If they are not, let them close slowly, the way they do when something interesting has your full attention and you simply forget to keep looking at the room around you. Picture yourself somewhere high, not on a building, not on a mountain, higher than that. Above the clouds, above the atmosphere, above the thin blue line that separates everything you have ever known from the silence of space. You are floating, and far ahead of you, not threatening, not rushing toward you, simply present the way a very large and very quiet thing is present. Something is waiting. You cannot see it directly. You will never see it directly. It is black against black, the darkest object in a dark universe. Invisible the way a held breath is invisible. You know something is there, not because of what you see, but because of what you feel. The stars around it are bending, not moving, bending. Their light curving gently inward, the way water curves around a stone, the way a dream bends at the edges when you are almost asleep. The entire background of the universe is warping into a thin, bright ring. Every star, every galaxy, every photon that has crossed billions of light years is being gathered, slowly, into a circle of light around something that produces no light of its own. That circle is real. We photographed it in 2019. A team of scientists, 200 people, 8 telescopes spread across the entire planet, working together for years to capture a single image. A ring of fire around an absence, and tonight you are going to cross it. Over the next 2 hours, we are going to travel somewhere physics itself becomes uncertain. We will pass through the event horizon, the point of no return, and discover why crossing it feels like nothing at all from the inside, yet looks like the end of everything from the outside. We will fall through regions where space and time trade places, where the future is no longer ahead of you, but below you, where every direction you could possibly move leads only one way. We will sit with the singularity, the place at the center where our best equations break down completely, where the universe seems to be hiding something it does not yet want us to understand. And we will ask the question that has kept physicists awake for 50 years. When everything that falls into a black hole is gone, when the light is gone, the matter is gone, the heat is gone, does the information survive? Does something remember what was there? Does the universe forget? These are not small questions. They sit at the exact place where our two greatest theories of reality, general relativity, and quantum mechanics point at each other and disagree completely. And the answer, when we finally find it, will not just explain black holes. It will rewrite what we know about space, time, and what it means for something to exist at all. You do not need to remember any of this tomorrow. You do not need to take notes, or follow every argument, or hold every concept in perfect clarity. These ideas are designed to drift through you the way music drifts through a room. Some of it settles, some of it simply passes, and all of it is pleasant to be near. What I hope you carry with you, somewhere beneath thought, is simply this. There is a place in the universe where the rules stop, where the mathematics reaches its edge and looks over, uncertain, where something is happening that no living mind has ever witnessed and no instrument has ever measured. And tonight, in the quiet of wherever you are lying, with your eyes closed and your breathing slow, you are going there. Let's begin. Imagine you are still floating. The earth behind you is a pale blue point now, small enough to cover with the tip of your finger, fragile enough that the gesture feels almost unkind. Everything you have ever known is in that point, every person, every city, every ocean, every afternoon that ever felt too long or too short, all of it behind you, shrinking, and ahead of you, the black hole waits, not rushing toward you, not threatening, simply present the way a very large and very quiet thing is present, the way the ocean is present, on a night when you cannot see it, but you can feel the air has changed. Right now, as you lie still, the same gravity that holds you against the earth is the force we are traveling toward tonight. The same invisible pull that keeps the moon in its orbit, that keeps the oceans from drifting into space, that keeps your body heavy and warm against whatever is beneath you right now. Gravity, the oldest force, the quietest one, and somewhere ahead, it has become something else entirely. You are still far away, far enough that the stars ahead look almost normal, almost. If you were not paying attention, you might not notice anything unusual at all, but you are paying attention. And once you see what the stars are doing, you cannot stop seeing it. They are drifting, not moving across the sky the way stars move on a long exposure photograph, drifting slowly, almost lazily, toward a center that produces no light of its own, as if the universe has a drain and everything is sliding toward it, with a patience that makes the words slow feel inadequate. Let your breathing slow now too. There is no hurry here. The black hole has been waiting for billions of years. It will wait a little longer. And you have nowhere to be tonight, except exactly where you are. Warm, still, carried gently forward by a story that has no rush in it at all. The first thing you really notice is what is happening to the light. Something impossible is occurring. Stars are appearing in places they should not be. Galaxies that should be hidden directly behind the black hole are visible. Their light has bent all the way around the outside of the gravitational field, curved so sharply that it arrives at your eyes from completely the wrong direction. You are seeing things that should be invisible. The universe is showing you its back. This effect has a name: gravitational lensing. You may have read about it once, in a classroom or a late-night article you have half forgotten, but no article prepared you for what it looks like from here. the entire background of the universe quietly rearranged, the geometry of everything subtly, inexplicably wrong. And yet, it is one of the most beautiful things you have ever seen. Then you see the ring, a perfect circle of light surrounding perfect darkness. You have seen the photograph, that image released in 2019, the first time humanity ever captured a black hole directly. But the photograph was taken from 55 million light-years away, assembled from radio waves, processed for years before a single image emerged. From here, it does not look like a photograph. It glows. This is the photon sphere, the place where gravity has become strong enough to hold light itself in orbit. Photons that entered this region at exactly the right angle and found themselves caught, not falling in, not escaping, but circling, going nowhere, forever, moving at the fastest speed the universe allows and still unable to leave. Right now, as you lie in the quiet of wherever you are, photons that have been orbiting that ring since before the Earth existed are still circling, still moving, still trapped in a loop that has no exit and no end. There is something almost peaceful about that, the universe holding its breath. But something else is happening now, something subtler, something you feel before you understand it. Time is changing, not dramatically, not in a way that trips an alarm, but your instruments know. The clock you carry is ticking at a rate that no longer matches the clock of someone watching you from far away. For every second passing here, slightly more than a second is passing there. The difference is almost nothing, almost, because here is what took us a century to truly accept. Gravity does not simply pull on matter. Gravity is a curvature of space-time itself. And a curvature of space is always, also, a curvature of time. The two are not separate. They were never separate. Einstein understood this in 1915 and wrote it into his equations, and physicists spent decades arguing about whether he could possibly be right. He was right. We have measured this effect with atomic clocks on satellites. We correct for it every day in the GPS system that guides people through unfamiliar cities in the middle of the night. Without that correction, navigation would drift by kilometers before morning. Time runs faster where gravity is weak. Time runs slower where gravity is strong. And right now, in the gravity ahead of you, time is running slower than it has ever run for anything alive. Feel the weight of your body for a moment, the specific heaviness of a human form at rest, the way the mattress or the pillow or the ground holds you exactly as you are, perfectly, without effort. That weight is gravity, the same force, the one we are moving toward. Except here, where you are lying now, it is gentle enough to sleep in. You are close enough now that the black hole has a presence, not a visual presence. It is still invisible, a darkness you identify only by the shape of everything around it, but a felt presence. The universe behind you has changed. Everything, every star, every galaxy, the pale blue point that was Earth, has been gathered by the bending of light into a shrinking circle at your back. 2 trillion galaxies, each containing hundreds of billions of suns, compressed by gravity into a disk of light that is getting smaller the further you go. Ahead of you, the darkness is getting larger, not rushing, simply growing. The way sleep grows at the end of a long evening gradually, around the edges of thought, until the thoughts themselves begin to soften, and the darkness is simply there, natural, expected, welcome. The photon sphere glows ahead of you, still and perfect, a ring of everything that tried to pass this point and could not. And beyond it, darkness, Somewhere behind you, impossibly far now, someone who loves you is going about their evening, making tea, perhaps, reading something, letting the day go the way days go when you stop fighting them. They do not know you are here, at the edge of the strangest place in the universe, floating in the gravity of something 4 million times heavier than our sun. They just know the night is quiet, and you are somewhere safe. Let that be true for a moment. You are somewhere safe. The black hole is ahead, patient and enormous, and deeply, deeply interesting. But you are not falling yet. You are only approaching, only watching, only letting the story carry you forward at whatever pace your breathing chooses. There is a boundary ahead, the last boundary. On the other side of it, the rules of the universe change in ways that no living thing has ever experienced and return to describe. On the other side of it, time and space trade places. On the other side of it, every direction you could possibly move leads to the same destination. In, only in. We call it the event horizon. And in the next part of tonight's journey, you are going to cross it. Not because you have to, but because you are curious. And because curiosity, in the end, is what brought every great mind to the edge of every great unknown and whispered the same quiet question into the dark. What is in there? Close your eyes a little more now. Let the weight of your body go. The event horizon is waiting, and it looks like nothing at all. You are here now. Not close, not almost. Here, the event horizon. And the first thing you notice, the thing nobody ever expects, is that you notice nothing at all. No alarm, no sound, no physical sensation of crossing from one kind of universe into another. No line drawn in space, no change in temperature, no shift in the light. The event horizon is not a surface. It is not a wall. It is not even a place, exactly. It is a mathematical boundary, a threshold, defined entirely by what becomes impossible on the other side of it. You crossed it. You just did not feel it happen. Let that settle for a moment. The most significant threshold in the known universe, the point beyond which nothing, not matter, not light, not information of any kind, has ever returned. And crossing it feels like crossing nothing at all. Lie still now. Feel the specific stillness of wherever you are. The way the room around you is just a room. The way the ceiling above you is just a ceiling. Ordinary things, perfectly ordinary, asking nothing of you. That is what the event horizon feels like from the inside. Ordinary. The stars are still visible behind you. The universe is still there, compressed now into a shrinking circle of light at your back, getting smaller, but still present, still real. You have not lost the world yet. You have simply moved to a place from which the world can no longer reach you. There is a difference between those two things. And right now, floating in the strange quiet just inside the event horizon, that difference feels important. But someone is watching you from outside. Someone who stayed behind at a safe distance, who watched you approach and kept watching as you moved closer to the ring of light, who is watching still or thinks they are watching still. What they see is not what is happening. As you move toward the event horizon, your image began to slow. Not because you were moving slowly, you were moving at a significant fraction of the speed of light. But because the light carrying your image back to them was fighting against the same gravity you were falling into, each photon of light reflecting off you had to climb a steeper and steeper gravitational hill to reach the eyes of the person watching. And as the hill got steeper, the light got slower. Not in reality. Light always travels at the speed of light. But in the time it took to arrive, each image of you taking longer and longer to escape, until at the exact moment you cross the event horizon, the light from that moment is still climbing, still trying to escape, still fighting gravity that has become infinite. From outside, you appear frozen, suspended at the edge of the event horizon, dimming slowly, reddening as your light loses energy to the climb, not moving, not falling, simply present at the boundary in a permanent image that will take an infinite amount of time to fade completely. You are inside. Your image is still outside. Two versions of the same moment, separated by a mathematics that has no mercy and no exceptions. The universe does this quietly. It does not announce its paradoxes. It does not slow down so you can follow. It simply continues running its equations at the same patient pace it has always run them, producing outcomes so strange that the humans who discovered them spent years arguing about whether they could possibly be real. They are real, right now, as you lie still in the quiet of wherever you are. The universe is doing this somewhere. Somewhere in the darkness between galaxies, something is crossing an event horizon. Something is suspended forever in someone else's view, while it continues falling in its own experience. Two realities, equally true, separated by a boundary made of nothing but mathematics. Feel how still your room is. The universe is enormous and strange and full of paradoxes that have no resolution. And you are here, in this room, warm and horizontal, breathing slowly, on the right side of every event horizon that has ever existed. That is not nothing. Now, something is happening to time. Not the gentle slowing you noticed as you approached. That was subtle. A clock running a few seconds slow, easily missed, easily corrected. This is different. Inside the event horizon, the relationship between space and time has changed at a fundamental level. Outside, you could choose your direction in space: forward, backward, left, right, up, down, 6 directions. Time was the one thing you could not choose. Time simply moved forward, whether you wanted it to or not. Inside, that has flipped. Space, here, has collapsed into a single direction. Not metaphorically, physically. Every possible path through space, every direction you could point yourself, every angle you could choose, every trajectory available to you leads toward the center. There is no sideways anymore. There is no turning around. Space itself has become a one-way street with no exits and no intersections. And time has opened up, not in a pleasant way, not in the way a free afternoon opens up, but in the mathematical sense. Time, inside the event horizon, has taken on some of the character that space used to have. It has become the dimension with freedom, the dimension you can, in some theoretical sense, navigate. The center of the black hole is not a place ahead of you. It is a moment in your future. Inevitable the way next Tuesday is inevitable. Unreachable in the sense that you cannot arrive before you arrive. Coming toward you whether you move or stay still, whether you struggle or surrender. As certain as every tomorrow that has ever followed, every tonight. Let that image drift now, the center coming toward you like a slow tide. Not violent, not sudden. Just present the way the end of a long evening is present long before it arrives, felt in the quality of the quiet, in the way the thoughts get softer and the body gets heavier, and the idea of sleep stops being an idea and starts being simply what is happening. You are not afraid here. There is nothing to be afraid of. Fear requires alternatives, the possibility that things could go differently. that a choice made now might change what comes next. Inside the event horizon, there are no alternatives. There is only the present moment and the mathematical certainty of what follows. And in a strange way, that is restful. The relieving of all responsibility, the universe deciding, simply and completely, what happens next. There is a debate among physicists about what you would find at the event horizon. Not inside it, not deeper in, right here, the exact boundary. One side says nothing. General relativity, Einstein's theory, the one that has been tested against every observation we have ever made, the one that predicted black holes before we knew they existed, says the event horizon, is smooth, unremarkable. A mathematical line in space with no physical feature to mark it. You pass through and continue. The other side says fire. In 2012, a group of physicists published a paper that sent shockwaves through theoretical physics. They argued that quantum mechanics, our other great theory of reality, equally tested, equally confirmed, demands something different. That the event horizon cannot be smooth. That the rules of quantum information require a wall of high-energy radiation at the boundary. That anything crossing the event horizon would be instantly incinerated. A firewall, not a metaphor. Literal fire, literal destruction. At the exact point where general relativity says you would feel nothing. Both theories are correct in every situation. We can test them. Both theories are confirmed by every experiment ever designed to challenge them. And here, at the event horizon of a black hole, they predict opposite things. One of them must be wrong. We do not know which one. This is the most uncomfortable position in all of science, not ignorance, which is familiar and navigable, but contradiction. Two maps of the same territory that agree on everything except the one place you most need them to agree. The universe has not told us yet. It keeps the answer inside. Feel your breathing now, in and out. The rhythm your body has maintained every moment of your life, without being asked, without instructions, without ever once forgetting what to do next. Your body knows things your mind does not have to manage. The universe is like this too. It runs its equations without asking anyone's permission. The event horizon exists. The time dilation exists. The paradoxes exist. All of it running quietly in the background of a cosmos that does not pause to explain itself. You do not need to understand all of it tonight. You only need to rest inside it. The way you rest inside every night, without understanding the neuroscience of sleep, the chemistry of dreams, the precise mechanism by which consciousness dims and the body repairs itself in the dark, you trust the process. The universe trusts its equations, and somewhere between those two trusts, between your body knowing how to sleep and the universe knowing how to curve space-time, tonight's journey continues. Deeper now, past the firewall debate, past the question of what the boundary feels like, past the event horizon entirely. You are inside a black hole. The ring of light behind you is getting smaller. The universe is still visible, compressed into a circle that is shrinking, dimming. The stars at its edge reddening as their light loses more and more energy, fighting a gravity it can no longer escape. Soon that circle will close, and you will be alone with the dark, and the center will be coming toward you. The way morning comes toward you now, quietly, certainly, still far enough away that there is time to rest, time to dream, time to let the ideas from tonight's journey settle into whatever quiet form they choose to take when conscious thought finally lets them go. We are not at the center yet. There is still time. Rest a little deeper now and let the darkness carry you forward. You are falling now. Not the falling of dreams, that sudden drop, that lurch in the stomach, that gasp before you catch yourself. This is different. This is the most gentle falling imaginable. No wind, no resistance, no sensation of movement at all. Just the universe, rearranging itself around you, quietly, without asking. The circle of the outside world is still visible behind you, still there, but smaller now, a disk of compressed light, containing everything that has ever existed outside this place. 2 trillion galaxies, 400 billion stars in your galaxy alone. The pale blue point that was Earth, that is Earth, that will be Earth, long after tonight has passed and morning has come, and you have woken up and made coffee and forgotten most of what you heard here. All of it, in a circle that is slowly closing. Let your eyes stay closed a little heavier now. The light from outside is still arriving, still reaching you, but it is arriving strangely blue-shifted, compressed, the wavelengths shortened by the enormous gravitational fall, so that light which left distant stars as gentle red becomes harsh blue by the time it finds you here. The universe is being translated into a language it was not meant to speak, and still it is beautiful. Your body, if it were here, would be changing. Not immediately, not all at once, but the tidal forces, the difference in gravity between your head and your feet, between the side of you closer to the center and the side of you further away, are beginning to be measurable. This is the beginning of something physicists call spaghettification. The word is almost funny. It was coined because someone needed a word for something so extreme it had no precedent in ordinary experience. And the closest image available was pasta being stretched between 2 hands, pulled long and thin by forces working in opposite directions. That is what would happen to matter here. Not to you, not yet, not at this distance, but to anything that fell into a stellar black hole, one of the smaller ones, just a few times the mass of the Sun. The tidal forces at the event horizon would already be fatal. The difference in gravity between near and far would be strong enough to pull a human body apart before it ever crossed the boundary. The black hole at the center of the Milky Way is different. 4 million solar masses. An event horizon so large that the tidal forces at the boundary are actually gentle, comparable to what you experience standing on the surface of the Earth. A body could cross it without feeling anything unusual, without any alarm, any warning, any indication that the most significant threshold in physics had just been passed. You would simply be inside. The way you are inside this night, right now, inside the quiet, inside the dark, inside the slow drift towards sleep, without noticing the exact moment the day became something else. Right now, as you lie still, your atoms are mostly empty space. This is something worth holding for a moment. The solid feeling of the mattress beneath you, the weight of the blanket, the particular texture of the pillow against your face, all of it is almost entirely nothing. The atoms that make up your body and the atoms that make up everything around you are vanishingly small, dense nuclei, surrounded by vast clouds of electrons, and the space between them is proportionally as empty as the space between stars. You are mostly emptiness, feeling the pressure of other emptiness. The universe has arranged nothing into something so convincingly that it holds you, warms you, knows you by name. Inside the black hole, that arrangement is beginning to be tested. The forces here are asking matter questions that matter has never been asked at this intensity. What are you, really, when the pressure becomes this extreme? When the distances shrink to scales where ordinary physics no longer has jurisdiction, when the empty space inside atoms begins to have nowhere left to be empty, we do not know the answer, not because we have not tried, because the mathematics that would answer it does not yet exist. Time is doing something strange, not slowing, exactly, not the familiar time dilation of gravity that we have measured and corrected for in satellites. Something more fundamental. Outside the event horizon, time was the dimension you could not choose. It moved forward, whether you agreed or not. Space was where your freedom lived. You could go left or right, up or down, toward or away. 6 directions, all available, all real. Inside, that freedom has relocated. Space has collapsed into one direction, not in a way you can feel with your body, not in a way that creates a sensation of compression or confinement, but in the strict mathematical sense. Every geodesic, every possible path through space-time, every trajectory available to any object or any particle of light curves inward, toward the center. Inevitably, the center is not a place you are moving toward. It is a moment that is moving toward you, the way tomorrow is moving toward you right now as you lie here. Not because you are traveling toward tomorrow, but because time moves, and tomorrow is where it is taking you. And there is a profound difference between those two things that most people never have occasion to notice. Inside a black hole, you notice. Let that thought drift now. The center, coming like a tide, slow and certain, not something to be frightened of. Nothing here requires fear, and fear serves no practical purpose in a place where all practical purposes have been suspended. Just something to be present with. The way you are present with sleep coming. That same quality of approach, the edges of thought softening, the details of the day becoming less insistent, the particular weight of consciousness beginning to shift into something lighter and less defined. Sleep is coming for you too, in its own way. Let it come. The outside world is almost gone now. The circle behind you has narrowed to a point. Not closed, not yet, but nearly. A single bright spot containing everything, shrinking towards something too small to be called a window, too small to be called a door, too small to be anything except the last visible evidence that an outside exists at all. And then it closes, and you are alone with the dark. Not the dark of a room with the lights off, not the dark of a clear night between city lights. The dark of a place where no light has ever originated, where no light from outside can arrive, where the photons that exist here are only those that fell in with you, following the same inward path, unable to turn back. A darkness that is not the absence of light, a darkness that is the presence of something else entirely. The center is closer now. You cannot see it. You cannot feel it with your skin, or measure it with your hands. But the mathematics says it is there ahead of you in time, approaching the way all futures approach. At the same rate, time has always moved, 1 second per second, unremarkable in its pace, if not in its destination. What is at the center? Rest with that question for a moment. Not the answer, the question itself. The way it feels to hold a question that nobody alive has ever answered. Not because they have not tried. Some of the greatest minds in the history of science have spent their careers trying, but because the question exists at the exact boundary of what human knowledge can currently reach. Past this point, the map ends. And in the next part of tonight's journey, we go past the map. Every map has an edge. Not because the territory ends there, but because the mapmaker ran out of information, ran out of tools, ran out of the ability to measure what lay further on, and rather than guess, drew a line and left the rest blank. The singularity is where the map ends, not at the edge of the known universe, not at the boundary of the observable cosmos. Here, inside this black hole, at a distance from the center that the mathematics can calculate but cannot describe, the map of physical reality as we understand it, runs out completely, and what lies beyond it, we do not know. The equations predict a singularity, a point, dimensionless, occupying no space, containing all the mass of the black hole, compressed into something that is not really a something at all, a location in mathematics where the density becomes infinite, where the curvature of space-time becomes infinite, where every quantity that should have a value instead produces a result that the equations themselves cannot accommodate. Infinity appearing in an equation is not an answer. It is a confession that the equation has been pushed past where it works, that the theory describing the universe has reached a region of the universe it was not built to describe, that something deeper is needed, a physics beyond our current physics, a mathematics that does not yet exist, a framework that can look at what happens in the final moments of collapse and produce a number instead of a breakdown. We do not have that framework yet. And so, the singularity sits at the center of every black hole in the universe, at the center of the one you are inside right now, as a question mark written in the language of mathematics, large enough to be seen from the edges of theoretical physics, impossible to read up close. Let your breathing slow a little more now. In, slowly, and out. There is something strangely peaceful about the edge of knowledge, about the place where the certainty stops and the honest uncertainty begins. We spend so much of our lives surrounded by things that are supposed to be known, answers that should exist, questions that should have resolutions, problems that should be solvable if only the right person applied the right method with the right tools. And then there is this, a point at the center of a collapsed star where the best physics humanity has ever produced simply stops working. Not wrong, not contradicted by experiment or observation, simply beyond its own range. The way a ruler can measure the length of a room but cannot measure the temperature of the air inside it. Not wrong, just not made for that. The singularity is not made for our current mathematics, and our current mathematics is not made for the singularity. They regard each other from a distance, and neither blinks. But here is what we think might be true. Most physicists believe the singularity is not real. Not in the sense that black holes are not real, they are demonstrably, observably, undeniably. But in the sense that the singularity appearing in the equations is most likely a signal that the equations have failed, not a description of something that physically exists. When infinity appears in physics, history suggests it means the theory is incomplete. Not wrong. Incomplete. Newton's gravity was not wrong. It described the orbit of every planet with extraordinary precision for 200 years. But it was incomplete, unable to account for the slight shift in Mercury's orbit, unable to describe what happened to space and time near massive objects, unable to explain gravity at the deepest level. Einstein completed it, extended it into territory Newton's mathematics could not reach. The singularity is telling us that general relativity needs completing, that somewhere, in the extreme conditions of the black hole's center, quantum mechanics must take over, must replace the smooth curves of space-time with something grainier, something discrete, something built from the strange probabilistic rules that govern the very small. What that replacement looks like, we do not yet know. There are candidates. Loop quantum gravity suggests that space itself is not continuous, not a smooth fabric that can be curved and bent infinitely, but is instead made of discrete chunks, the smallest possible units of space, below which the concept of distance loses meaning. In this picture, the singularity cannot form. The collapse reaches the smallest possible scale of space and stops. Bounces, perhaps. becomes something else, a bounce, inside a black hole, where the collapsing matter reaches the quantum floor of space and rebounds not outward into the black hole, but sideways, into a new region of space-time, disconnected from ours, expanding into what might be described as a new universe, a baby universe. Born from the death of a star, the idea sounds like poetry. It is actually mathematics, peer-reviewed, carefully reasoned, not confirmed, but not dismissed. A serious proposal by serious physicists working at the edge of what can currently be said with rigor. String theory offers different possibilities, extra dimensions, wrapped so small they are invisible at ordinary scales, that open up under the extreme conditions of the collapse and provide new directions for matter to inhabit, preventing the singularity by giving matter somewhere else to go. Different maps of the same unknown territory. Different ways of saying, we think something is there. We think we understand its shape. We cannot yet be certain. Right now, as you lie still, your body is doing something the singularity cannot do. It is resting comfortably with uncertainty. The mind does not need to resolve every question before it can sleep. The body does not need every answer before it can be warm and heavy and horizontal and drifting. Some of the most restful states are the ones where the questions are still present but no longer urgent, where curiosity has done its work for the evening and is content to wait for morning. You are good at this. Every night of your life, you have surrendered consciousness without knowing exactly where it goes, without a complete theory of sleep or dreams, or the mechanism by which the self reassembles itself each morning. You trust the process. The singularity asks the same trust, not of you, of physics, of the next generation of theories that will extend into the territory the current ones cannot reach. The answer is there. It is simply waiting for the mathematics to catch up. But before we leave this place, this point at the center where the map ends and the honest unknown begins, there is one more thing worth holding. One more question that the singularity raises that is not about physics at all, not about equations or theories or the structure of space-time, about memory, about whether the universe forgets. Everything that has ever fallen into this black hole is here. Stars that collapsed billions of years ago, gas clouds that drifted too close across the history of the galaxy, light that entered at the wrong angle and could not escape. The information in the precise physical sense of the word, every detail of every particle's state, every quantum number, every relationship of all of it is here. Or is it? This is the question that has occupied theoretical physics for 50 years. The question we carry with us now, out of this part of the journey and into the next. Not what is at the singularity, but what happens to everything that reaches it. Does the universe keep the memory, or does it let it go? Rest now. The singularity is behind you. Not because you have passed through it, nothing passes through it, nothing returns from it. That is the definition of what it is. But because tonight, in this telling, we pause here, at the edge, at the last place the mathematics can reach, and we breathe, and we carry the question forward into the next part of tonight's journey, where the real mystery begins. Stephen Hawking spent the last decades of his life on a question he could not answer, not for lack of trying, not for lack of intelligence or persistence, or the extraordinary geometric intuition that let him navigate mathematical landscapes. Most physicists could only approach with years of careful calculation. He tried. He wrote papers. He changed his mind. He changed his mind again. He died in 2018, having spent 40 years circling a problem that remains, to this day, unsolved. The problem is simple to state. When a black hole evaporates, when it finally, after an almost incomprehensibly long time, loses all its mass through Hawking radiation and disappears, where does the information go? Information, in the physical sense, is not data on a screen. It is the complete description of a physical system. Every detail, every particle's position, momentum, spin, every quantum number of every constituent of every object that has ever fallen into the black hole. The complete record of everything that was, encoded in the arrangement of matter and energy. Physics has a law about information. It cannot be destroyed. Not lost, not hidden, not misplaced, not temporarily unavailable. Destroyed. Gone completely, with no recovery possible. No record remaining anywhere in the universe. This law comes from quantum mechanics. It is called unitarity, and it has been confirmed by every experiment ever designed to test it. Information is conserved the way energy is conserved. It changes form, it moves, it becomes harder to read, but it does not cease to exist. Black holes appear to violate this law completely. Everything that falls into a black hole, every particle, every quantum state, every piece of information about every object is trapped behind the event horizon, inaccessible to the outside universe, apparently lost, and then Hawking radiation carries the mass away, slowly, over timescales that make the current age of the universe feel brief, but completely. Every last quantum of mass eventually radiated away, the black hole shrinking and heating, and finally, in a last burst of energy, disappearing. And if the Hawking radiation is truly random, truly thermal, carrying no information about what fell in then when the black hole is gone, the information is gone with it, destroyed, which quantum mechanics says is impossible. This is the black hole information paradox, and it is not a small problem. It sits at the intersection of the two greatest theories in the history of physics, general relativity, and quantum mechanics, and forces them into direct contradiction. Not a subtle disagreement about a minor effect at the edge of measurement. A fundamental, irreconcilable conflict about whether the universe keeps records. General relativity says the information falls to the singularity and is lost. Quantum mechanics says information cannot be lost. Both theories are correct. In every domain, we can test them. And here, they cannot both be right. Right now, as you lie still, the universe is keeping records. Every position of every atom in your body, every state of every particle in the room around you, every quantum number of every electron, in every molecule of the air you are breathing in and out, slowly, right now. The universe knows this, not consciously, not in the way a person knows something, but in the physical sense the information exists, encoded in the state of the universe. In principle, recoverable. In principle, real. You are part of the universe's memory. Everything you are, everything you have been, everything that has ever happened to the matter that currently makes up your body, it is all, in principle, there, written in the language of physics, conserved by laws that have held without exception across 14 billion years of cosmic history. And somewhere, inside a black hole, that conservation appears to fail. The universe appears to forget. Hawking, in his original 1974 paper, concluded that information was lost, that the black hole information paradox was a genuine paradox, that quantum mechanics was wrong about information conservation, or general relativity was wrong about the event horizon, or something else we had not yet understood was broken. He spent the next 30 years defending this position. Then, in 2004, he changed his mind. In a famous lecture in Dublin, Hawking announced that he believed information was not lost, that it escaped. Somehow, encoded in the Hawking radiation in correlations too subtle to measure but real, in principle, nonetheless. He conceded a bet he had made with the physicist John Preskill. The prize was an encyclopedia, a repository of information chosen, Hawking said, because information should be freely accessible. The audience laughed, but the problem was not solved. Changing his mind about the conclusion did not mean Hawking had found the mechanism. The question of how information escapes what physical process carries it out of the black hole, through the event horizon that nothing is supposed to cross, in a form that preserves the quantum correlations without violating general relativity, remained completely open. It still does. Then came the firewall. In 2012, a group of physicists, Almheri, Marolf, Polchinski, and Sully, known collectively as AMPS, published a paper that changed the conversation entirely. They were trying to show how information could escape in the Hawking radiation. Instead, they found a contradiction so severe it suggested that one of three things must be true, and all three seemed impossible. Either information is lost, violating quantum mechanics, or the event horizon is not smooth, there is a wall of high-energy radiation at the boundary, a firewall that destroys anything crossing it, violating the equivalence principle that is the foundation of general relativity. Or something even stranger, some principle of physics we currently take for granted, must be wrong in a way we do not yet understand. Three doors, all of them, in different ways, lead to somewhere physics has never been. The firewall paradox is not solved. As of tonight, it remains one of the deepest open problems in theoretical physics. Some of the greatest minds working today at the boundary between quantum mechanics, gravity, and information theory are spending their careers on it, and the universe, patient and silent, keeps the answer inside. Let your thoughts soften now. Not away from the question can stay. It does not need to be resolved tonight. It does not need to be resolved ever, for you, in the sense that the universe will keep running whether or not we understand this particular corner of it. The firewall paradox is not your problem to solve tonight. It is your problem to rest inside, to hold lightly. The way you hold a question at the edge of sleep, not gripping it, not forcing it, just letting it be present in the way the dark is present, the way the quiet is present, the way the weight of your body against whatever is beneath you is present. A question with no answer tonight. That is allowed. That is, in fact, exactly where the best science lives. There is another mystery, deeper, stranger, and in some ways more beautiful than the information paradox. It connects black holes to something you would never expect them to be connected to, the fabric of space-time itself. In 1935, Einstein and a physicist named Nathan Rosen were working with the equations of general relativity and found something unusual. A solution to the equations that describe two black holes connected by a tunnel, a bridge through space-time, connecting two separate regions of the universe, or perhaps two entirely separate universes. They called it an Einstein-Rosen bridge. We call it a wormhole. The mathematics allowed it. Whether the universe chose to make one, whether the physical conditions required to form and maintain such a structure could ever actually occur, was another question. Wormholes, the equations suggested, would be unstable. They would collapse faster than anything could cross them. Keeping one open would require a form of matter with properties so unusual negative energy density that we have never observed it in any quantity sufficient for the purpose. For decades, wormholes were considered mathematical curiosities, permitted by the equations, irrelevant to reality. Then something changed. In 2013, a paper appeared that connected two ideas nobody had thought to connect: quantum entanglement, the phenomenon where two particles become correlated in such a way that measuring one instantly affects the other, regardless of the distance between them and wormholes. The paper was titled ER equals EPR. ER for Einstein-Rosen, the wormhole. EPR for Einstein-Podolsky-Rosen, the entanglement. The claim was extraordinary, that these two things, quantum entanglement, which connects particles across any distance without any signal passing between them, and wormholes, which connect regions of space-time through a geometric tunnel, are not just similar, are not just analogous, are the same thing, that entangled particles are connected by a microscopic wormhole, that the geometry of space-time and the correlations of quantum mechanics are two different languages describing the same reality. If this is true, and it remains, as of tonight, a conjecture, a serious conjecture taken seriously by serious physicists, but not proven, then the fabric of space-time is woven from quantum entanglement. Space itself is an emergent property of the quantum correlations between the particles that make it up. Space is not the stage on which physics occurs. Space is the consequence of physics occurring. Right now, as you lie still, the atoms of your body are entangled with the atoms of the world around you. Not dramatically, not in a way that produces any effect you can measure or feel, but in the technical quantum sense. The particles that make up your body have interacted with the particles of the air and the mattress and the pillow, and those interactions have created correlations, quantum relationships between states that persist. You are, in the tiniest and most technical of ways, woven into the fabric of the space around you, not metaphorically, physically. If ER equals EPR is right, then the space between you and the wall of your room is partially constituted by the quantum entanglements between the particles on both sides. Space is relationship. Emptiness is connection. The void between things is made of the correlations between things. And if that is true, then black holes, where the curvature of space-time becomes extreme, where the geometry changes most dramatically, are places where the quantum correlations have become so intense, so concentrated, that space itself has changed character. The event horizon is not just a boundary in space. It is a boundary in the quantum relationships between the inside and the outside. And the information paradox, the question of whether what falls in is remembered or forgotten, becomes a question about whether those quantum correlations survive, whether the entanglement persists, whether space, which is made of relationship, can be torn by a boundary made of the absence of relationship. We do not know. That is the honest answer. We do not know whether information survives. We do not know whether the firewall exists. We do not know what happens at the singularity. We do not know whether wormholes are real, whether space-time is made of entanglement, whether the universe we inhabit was born inside a black hole in some larger universe, whether black holes in our universe are giving birth to new universes right now. These are not small unknowns at the edge of a mostly complete picture. They are central unknowns, foundational ones. The answers would change not just what we know about black holes, but what we know about space, time, information, and the nature of reality itself. The universe is keeping its deepest secrets inside the darkest objects it makes. And the humans who study those secrets spend their careers standing at the event horizon of understanding close enough to see the shape of what they do not know, not yet close enough to cross into knowing it. Let the questions rest now, all of them. The information paradox, the firewall, the wormhole, the singularity, the baby universes, the entangled fabric of space, all of it. Let them settle the way ideas settle when you stop trying to hold them and just let them be present somewhere in the background of thought. Quiet, patient, no longer requiring anything of you tonight. The universe has been holding these questions for billions of years. It can hold them a little longer. And you, warm, still, breathing slowly, on the right side of every event horizon that has ever existed, you have done something tonight that most people never do. You have gone to the edge of what is known. You have looked over, and you have rested there, comfortable with the dark on the other side, unafraid of the questions that have no answers yet. That is not a small thing. There is one more part of tonight's journey. The long way back, the slow road out. Not through the event horizon, nothing comes back that way, but through time. Through the billions and trillions of years it takes for a black hole to give back, through Hawking radiation, every last quantum of what it took in. Through the final moment, when the last black hole in the universe disappears, and the universe is left with whatever remains. Rest now, deeply. Let the weight of everything you have heard tonight settle into whatever quiet form it chooses. The journey is almost complete, and the ending, when it comes, is one of the most beautiful things physics has ever imagined. Nothing escapes a black hole. You have heard this. You believe it. The mathematics confirms it. The observations support it. The entire structure of general relativity is built on it. The event horizon is the point of no return. Nothing that crosses it comes back. And yet, the black hole is losing mass right now, tonight. The black hole at the center of our galaxy, 4 million times the mass of our sun, patient and ancient and dark, is losing mass. Not quickly, not in any way that will matter for longer than any civilization has ever lasted or will ever last, but losing it, slowly, continuously, in the quietest possible way, through something that should not exist. Stephen Hawking was 32 years old when he found it. It was 1974. He was already losing the use of his hands, already beginning the long physical diminishment that would eventually leave him with only the muscles of one cheek to communicate with the world. And he was sitting with the mathematics of black holes and quantum mechanics, two theories that were not supposed to interact, two frameworks that physicists generally kept carefully separated, and he followed the equations somewhere they had not been followed before, to the edge of the event horizon. At the quantum level, what he found there was this: empty space is not empty. This is one of the strangest confirmed facts in all of physics, and it is worth holding for a moment before continuing. The vacuum, the space between particles, between atoms, between stars, is not a passive emptiness waiting to be filled. It is an active, seething, restless medium in which particle-antiparticle pairs are constantly flickering into existence and back out again, born from the energy of the vacuum itself, living for a fraction of a second before finding each other and annihilating back into nothing. This is not a metaphor. It is not a model. It has measurable consequences, effects on atomic energy levels, on the behavior of electrons, on forces between closely spaced metal plates. The quantum vacuum is real, and it is never truly still. It is flickering right now in the space between the atoms of your body, in the space between your hand and the wall, in the space between every object in the universe, always, without pause. At the event horizon of a black hole, this constant flickering becomes something else. A pair of particles appears as pairs always appear, everywhere, always right at the boundary, one particle on each side. Under ordinary circumstances, They would find each other within an instant and annihilate. The pair would borrow its energy from the vacuum and return it, leaving no trace. But the event horizon is there, and the event horizon separates them before they can find each other. One particle falls inward into the black hole, adding its energy to the interior, becoming part of the inaccessible mass inside. The other particle, freed from the annihilation that would have been its fate, escapes outward into the universe. It becomes real, a real particle with real energy, traveling outward from the black hole into the space beyond, carrying with it a small, almost impossibly small, amount of energy that used to belong to the black hole. This is Hawking radiation, not a beam, not a glow visible to any instrument we currently possess. A trickle, a whisper, a process so slow and so faint that for any black hole of the size we know about, the radiation is billions of times colder than the coldest place in the observable universe. Unmeasurable, undetectable, with anything we have, but real. The mathematics says it is real. And the mathematics of quantum field theory has never been wrong about anything we have been able to test. The black hole is evaporating. Let your breathing settle now. The idea is simple enough to hold without effort, without concentration, without the particular kind of mental grip that exhausts you. Just let it be present. The darkest, densest, most permanent seeming objects in the universe are slowly, patiently giving themselves back. Not because they choose to, not because something is taking from them, but because the quantum nature of empty space makes a tiny theft at their boundary, over and over, forever, until there is nothing left to take. The universe reclaims what it gave. Eventually, as the black hole loses mass, something counterintuitive happens. It gets hotter. This is one of those places where physics does something so backward that the mind resists it initially, and then, once accepted, finds it almost elegant. For ordinary objects, losing energy means cooling down. A cup of coffee cools as it loses heat to the room. A fire dims as it burns through its fuel. The relationship between energy and temperature runs in one direction. More energy, more heat. Black holes run the other way. As a black hole loses mass through Hawking radiation, its event horizon shrinks. A smaller event horizon means stronger gravity at the boundary. Stronger gravity at the boundary means the quantum effects are more intense. More intense quantum effects mean more radiation. More radiation means faster mass loss. Faster mass loss means the event horizon shrinks faster. The smaller it gets, the faster it shrinks. The hotter it gets, the faster it radiates. For most of a black hole's life, this is irrelevant. The process is so slow that the acceleration toward the end is still, by any human measure, incomprehensibly gradual. But in the final moments, the final seconds, the final fractions of a second, the process becomes rapid. The black hole is no longer cold and dark and patient. It is hot, blazing, radiating with an intensity that increases as the mass decreases. A feedback loop running to its conclusion, faster and faster and faster, until a flash, brief, brilliant. The last of the mass converted entirely into energy and radiated outward in a final burst. A moment of extraordinary brightness from something that was, for most of its existence, the darkest object in the universe. And then, nothing. Where there was once a black hole, perhaps a stellar black hole, a few times the mass of the Sun, formed when a massive star collapsed before the Earth existed, there is now only the faint, dispersing remnant of a final burst of radiation, spreading outward into a universe that has grown old and dark around it. the black hole is gone, not collapsed into something smaller, not transformed into a different kind of object. Gone. The mass converted to energy and released. The event horizon shrunk to nothing. The singularity, if it ever truly existed, no longer present in any form. Just the echo, fading. Right now, as you lie here, the universe is doing this somewhere. Not to a stellar black hole, those take longer than the current age of the universe to evaporate by a factor so large the number has no meaning in ordinary terms. But to smaller black holes, if they exist, primordial black holes, formed in the first fractions of a second after the Big Bang from regions of extreme density, some of them small enough that the evaporation timescale is measured in billions of years, rather than something incomprehensible. Some of them may be finishing right now. Somewhere in the universe tonight, a black hole that formed before the Earth existed, that has been slowly, quietly evaporating across the entire history of our solar system, may be reaching its final moments, getting smaller, getting hotter, approaching the last fraction of a second, and you will never know. The flash, if it happens, is too far away, the radiation too faint, the universe too large for the ending of one small ancient object to reach the ears of anything that might want to hear it. It ends in private, the way most things end. Now imagine further, much further, past the death of our sun 5 billion years from now, its hydrogen exhausted, expanding into a red giant, then shedding its outer layers into a glowing planetary nebula, leaving behind a white dwarf cooling slowly in the dark. Past the cooling of that white dwarf into a black dwarf, cold, dense, invisible, drifting through a galaxy that is itself aging, its star formation slowing, its brightest lights going out one by one, past the era of stars entirely. 100 trillion years from now, a number so large that the current age of the universe is to it, as a single day is to the current age of the universe. The last red dwarf will burn through the last of its hydrogen and go dark, not explode, not collapse dramatically, simply dim and stop. The universe will be dark. Not absolutely dark, the cosmic microwave background will still be present, stretched now to wavelengths so long they carry almost no energy, the temperature of the universe approaching but never quite reaching absolute zero. White dwarfs and neutron stars will still drift through the dark, cooling, invisible. And black holes, the stellar black holes and the supermassive black holes that once blazed at the centers of galaxies will still be there, patient, dark, the last large structures in the universe. This era has a name, the black hole era. It will last, depending on the mass of the largest black holes, somewhere between 10 to the power of 60 and 10 to the power of 100 years. Numbers that language cannot hold. Numbers that make a Google feel intimate and manageable. During this era, the black holes will be the universe. Everything else will have faded matter, decayed, stars gone cold, galaxies dispersed. And the black holes will drift through an expanding darkness, occasionally merging when two drift close enough, occasionally consuming the sparse remnants of ordinary matter that still exist, slowly, steadily, without hurry, doing what black holes do, existing, being massive, bending the space-time around them in the dark. And then, un by un, they begin to go. The smallest first, the black holes with the least mass, whose evaporation timescales are merely incomprehensibly long rather than incomprehensibly long squared. They shrink, they heat, they flash, they are gone. Then the larger ones. Then the larger ones still, each one taking its time, time measured in numbers that have no names, in durations that make the entire history of the universe from the Big Bang to tonight feel like the first microsecond of the first day of creation. But each one, eventually, reaching its final moments, getting smaller, getting hotter, flashing, going. The last black hole in the universe will be a large one. Not the largest, the supermassive black holes at the centers of long-dead galaxies will go before the very last, their size working against them in the final accounting, their evaporation timescales shorter than the smaller but still massive stellar remnants that drift through the dark. The last black hole will be somewhere in the middle range, drifting through a universe so old and so empty that the concept of distance has become almost meaningless. Nothing near enough to matter. No landmarks, no light sources, no reference points, just the black hole itself and the quantum vacuum flickering around it, stealing its mass, one particle pair at a time, getting smaller, getting hotter, for an unimaginable duration, alone in the dark. And then, a flash, brief, brilliant, the most energetic event in a universe that has forgotten what energy looks like. Light, real, visible light, the kind that warm things make when they are warm enough, appearing for the last time in the history of everything. And then darkness. A darkness so complete and so permanent that the word darkness is inadequate. Not the darkness of a room with the lights off, not the darkness of deep space between galaxies. The darkness of a universe that has finished everything it was going to do and is now simply expanding, cooling, waiting for a heat death that is no longer a future event, but the present condition of all things. This is how it ends. Not with a bang, not with a whimper. With a flash, the last black hole giving back what it took. The universe reclaiming the last of its concentrated mass. The final bright moment of a cosmos that began with the brightest moment imaginable and ends, after an incomprehensible journey, with one last light in the dark. And then the quiet, the permanent, irreversible, beautiful quiet of a universe at rest. Right now, as you lie still, none of this has happened yet. The sun is burning. The earth is warm. The oceans are full. The sky above you, though you cannot see it from where you are lying, contains stars. Real stars, burning right now. Young enough that their light is blue and their hydrogen is abundant and their futures extend for billions of years. You are early, cosmically, absurdly, wonderfully early. The universe is 13.8 billion years old, and the era of stars will last 100 trillion years. And you are here right at the beginning of it. In the first fraction of a percent of the time when stars will burn and light will exist and warm planets will orbit quiet suns. You did not arrive late to the universe. You arrived extraordinarily early, at the most interesting time. The time when things are still being made, when stars are still forming, when life, impossible, improbable, astonishing life, has found a way to exist in the thin, warm band between too hot and too cold, and has spent 4 billion years becoming complex enough to ask where it came from. You are the universe at its most awake, at its most curious, at its most alive. The iron in your blood was made in a star that died before the sun existed. The carbon in your cells was forged in a stellar furnace billions of years before the Earth had cooled enough to have an ocean. The hydrogen in the water in your body, the oldest part of you, was made in the first 3 minutes after the Big Bang, nearly 14 billion years ago, and has been cycling through stars and space and oceans and living things ever since. You are not separate from the story of black holes. You are made of the story of black holes. The star whose iron is in your blood, it died. It collapsed. Its core became a neutron star, or perhaps a black hole. And in dying, it scattered into space the heavy elements it had spent its life assembling. The elements that would eventually become the solar system, the Earth, the ocean, the first living things, the long chain of biology that ends tonight with you, lying still, breathing slowly, inside a universe that is still, despite everything, extraordinarily young. Take a slow breath now. Feel the weight of your body, the specific gravity of a human form at rest, the heaviness of the arms, the weight of the head, the particular pressure of the body against whatever is beneath it. Familiar, ordinary, yours. That weight is gravity, the same force we traveled toward tonight, the same force that bends light around black holes and slows time near massive objects and holds event horizons in place and will, over timescales beyond naming, evaporate the last black hole into a final flash of light. Gravity is holding you right now, gently, without drama, the way it has held you every night of your life, keeping you close to this warm planet, keeping the planet close to its star, keeping the star in its slow orbit around the center of the galaxy, keeping the galaxy in its place within the cosmic web that fills the observable universe in every direction. Gravity all the way up, gravity all the way down, and you, somewhere in the middle of it, warm and still and breathing. Tonight, you went inside a black hole. You floated toward it through a sky where stars were bending. You watched the photon sphere glow. You crossed the event horizon without feeling it, just as the physics promised, and found yourself in a place where every direction led inward and time had taken. The place of space and the outside universe had compressed into a prazed, closing circle of light. You sat with the singularity, where the mathematics runs out and the honest unknown begins. You held the information paradox, the firewall, the wormhole, the question of whether the universe keeps its memories. You watched a black hole evaporate, slowly, patiently, over timescales that make the current age of everything feel like a first breath. And you were there for the last one, the final flash, the moment the universe went quiet for good, and then you came back. Not through the event horizon, nothing comes back that way, but through the story, through the particular magic of a mind that can go somewhere in imagination and return with something it did not have before. A feeling, perhaps, not a fact, not a figure, not something that will survive a quiz or a casual conversation, just a feeling of having been somewhere vast, of having looked at something that does not give back what it takes and finding it somehow not frightening but beautiful, patient, honest in its darkness, a part of the same universe that made you, that holds you, that will one day reclaim the atoms you are made of and send them somewhere new. The black hole does not know you were there. It has no awareness of the journey tonight. No record of the questions asked in its vicinity, no memory of the voice that described its interior to a person lying still in a dark room on a warm planet, orbiting a middle-aged star in a quiet arm of an ordinary galaxy. But you were there, and the universe which does keep records, which does conserve information, which does remember, in the only way a physical system can remember, carries tonight with it. Somewhere in the quantum state of the universe, the fact of tonight exists. The fact of you lying here, having gone to the edge of the known and found it comfortable, having rested at the event horizon, having let the darkness be interesting rather than frightening, having trusted the quiet. Let your thoughts go now, all of them. The event horizon and the singularity and Hawking and the firewall and the last black hole going dark in a universe too old for language. Let them drift the way thoughts drift when sleep is very close, not gone, not forgotten, just no longer requiring anything of you. The universe is doing what it does. Black holes are evaporating at rates too slow to measure. Stars are burning on the other side of this planet. The galaxy is turning at 230 kilometers per second, carrying you and everything you have ever known in a slow circle that takes 225 million years to complete. And you are here, still, warm, breathing, on the right side of every event horizon that has ever existed, in the most interesting moment in the history of the universe, going to sleep. If you happen to still be awake, the next journey is waiting for you. But if sleep has found you first, good. That is exactly what tonight was for. Rest well, dream softly, and thank you, truly, for going inside a black hole with us tonight. Good night.